touched something here. Okay. So I want us to decompose this. And can anyone tell us the first function? By decomposing again, I would like us to imagine, you evaluate, L-U-A-T-E, evaluate for x equals 10. What is the first function you will apply to 10? And I'll write it here.
The power.
Good. So just dictate it and I'll write it.
E to the 4x.
You said the power. You didn't say the exponent.
Oh, sure. 4x.
Excellent. Excellent. Number 2. What is the next function that I apply to the result of 4x?
E.
E is not a function. E is a number. Which function you're yes, awesome. Which function I apply now to the result of e to the x? That it's covered here. It's covered. Which function I apply to this? So let's say I get 15. Which function I apply now to 15?
I think the power?
Never. Never.
So then it would be sine.
Exactly. Not sine. Sine is not a function.
Sine x.
Awesome. What do I apply now to the number that is this?
Cosine x.
Nope, we're not there yet.
Oh, I missed it. The power.
Yes. So by saying power, what do I mean? What function do I really mean?
X to the 3rd.
Awesome. Finally, to x to the 3rd, to this number now, which function do I apply? I know, now it's silly. Cosine is not a function, but cosine,
X.
that's it. Was a lot. Now, the second question that I have here, steps in differentiating this one. So, number 2, to differentiate, just tell me the numbers. So this one's number 1, this is, and so on and so forth. What will you do first? What would you do?
Differentiate
Yes.
4x, which is 4.
Okay, one more time. One more time. So I have an onion. When I peel the onion to get to the inner, I differentiate. When I evaluate, I start from the innermost to the outer. For differentiating, I start with the outer and go into the innermost, 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 innermost till I'm done. So, what is the first function I need to differentiate? From
Cosine x.
yes. So the order is completely reversed. So I start with cosine, that will be number 5. Then I continue with this. Maybe that's confusing. Maybe I shouldn't put them in there. Just so number 5 is done first. Number 4 is second. Number 3 is third. Number 2 is fourth, and number 1 is the last one. So when I evaluate, I have to start with the inner, slowly, slowly, slowly till the outer. When I differentiate, I start with the outer till I get to the inner. So first I have to differentiate cosine. Maybe I should put, instead of these numbers, maybe I should put number 1 is cosine, number 2 is x to the 3rd, number 3 is sine x, number 4 is e to the x, and number 5 is 4x. So maybe those numbers were confusing. I wanted to just show the inverse. But maybe I should erase them, and that's probably better. Okay, now let's differentiate this function. what will I do with without my whiteout? Okay, so let's differentiate this function. We have to differentiate cosine first. So I have cosine. I have cosine of something, and I need to differentiate it. What will I write?
Negative sign X.
Awesome. Negative sign, not of x, but this whole thing. Good. So that will be of sine cubed of e to 4x. So this is done. Now I have to differentiate the power. I'm differentiating power times. I have a function to power 3. A function to power 3. How do I differentiate this function to power 3? What do I get?
3
Yes.
functions in the center.
Exactly. Sine squared of e to 4x times, so this is done, this is done. Now I have to differentiate sine.
Cosine.
Cosine of e to 4x. So I'm on page, I think 5. So times, of course, always multiply. No addition, subtraction. Okay, times. You said cosine of e to 4x. Now I have to differentiate e to 4x. In other words, how do I differentiate this? E to a function.
E to the function.
Yes, this is done, and now finally I have to differentiate 4x.
Quick question.
Yes,
When you differentiated x cubed,
Yes.
where did the x squared go that would follow it?
this one?
Oh, is that x?
So this is a the function that we have to differentiate, but this is not x, it's sine.
Oh, okay, I see.
Yeah, but this is what we are differentiating. We are differentiating the power, but the base is not x, but the base is sine.
Gotcha. Thank you.
Thank you. So then finally, times what? Yes. I will rearrange it a little bit. 4 times 3 times negative 1, so negative 12, and then sine of sine cubed of e to 4x times sine squared e to 4x times cosine e to 4x times e to 4x. Not a friendly situation. A lot of work on this one. Okay, any questions for me? Do you have other problems you need help with? Other problems you need help with? Anything else, or can we continue?
I know yesterday when you went over 3.11, you
Yes.
kind of said like this isn't going to be a huge thing right now. Just know these parts.
If you,
Are we going to go back to 3.11 at all?
not really. You mean finding limits or anything like that? Not really. But we can. If you want to go back, we can.
No, not specifically. It was just towards the end of the class, and I'll admit.
Yeah. Did you need to work on some other problems?
I need to go back into it before I ask for like problems on any of that. So
Okay. So we can look at another derivative if you like.
for the hyperbolic stuff.
Yeah. Let's
Sure.
no inverses. You can use the formulas. So we did this one, if I remember correctly, last time. Let's see if there is anything else. No, it ends. So we can look at another one. Yeah, why not? Let's look at 37. And we have h of x equals hyperbolic sine of x squared. Okay, so let's take a look at this one. Can anyone help with the derivative of this? First of all, what is the outer, what is the inner? Because we only have two here.
Hyperbolic sine is the outer, squared is the inner.
Yes. Good. So then we differentiate the outer and then times the derivative of the inner. So we differentiate the hyperbolic sine, which is hyperbolic cosine of x squared, times the inner function prime, which is
2x.
2x. Now, if you want to evaluate hyperbolic sine of 3, then you do have to use e to the third minus e to negative 3 divided by 2. I have not found, maybe there is a way, if you Google it and if you find it in your calculator, if there is a feature like this, let me know. I did not get the chance to look at it. But otherwise, if you need to determine hyperbolic sine 3, then you have to use the formula. Unless you find a way with the calculator. Good. Anything else you would like to ask from WebAssign, from homework, from anything? Oh, do you want to look at the discussion before we move on?
Yes, what is discussion?
Yes. Let me see where it is. So let's look at that quickly. Okay, what was it? So we had f of x equals sine x tangent x to differentiate. So we have f prime of x, sine prime is cosine x times tangent x, and plus sine x times secant squared x. You're not supposed to do anything else. And the limit, as x approaches 2 from either side, of sine x minus 2 divided by x squared minus 4. When you plug in 2, of course, you get 0 over 0. You can, right now, use L'Hopital's rule because you know how. Sine of x minus 2 prime will be cosine of x minus 2 times the inner function, which is 1, divided by 2x. Well, in this case, 2 minus 2 is 0, cosine 0 is 1, 2 times 2 is 4. Another option, if you don't want to use L'Hopital's rule, another option for this would be limit as x approaches 2 from sine x minus 2 over x minus 2 times x plus 2. Since this is my rectangle and rectangle and rectangle approaches 0 because this is x minus 2, all these are fulfill the condition for 1, and then 2 plus 2 is 1/4. Because this limit approaches 1. Or the limit is 1, but that function approaches 1. So either way, you have to get the same answer. Any questions on that? Okay, we continue then with something called implicit 3.5, implicit differentiation. What is this? Before we talk about implicit, let's talk about direct differentiation. This is what we've been doing or dealing with. I have a function which is x squared. I'm asked to differentiate it. I have the function, so f prime will be
2x.
That's it. Direct because the function was given to us. What about implicit? The function may not be given to us. Or we may be given an equation, but we will not be able to solve the equation for the function. I need to plug in my laptop. It's losing power. Okay. So for example, sine y plus 2xy equals 4 tangent x. So here's an equation. It has the function in it. No one can solve this a software, Maple, Mathematica, yes, probably they will be able to solve it and on 3 or 4 pages or more. But we are not able to solve this equation for y. However, we are asked to find dy over dx. In something like this, I will not use y prime. Can you? Yes. I don't recommend it, because it's a ambiguous notation in such a situation. We should always use dy over dx to solve the equation and find y prime. So we are asked to find the derivative of y, but we are not given y directly, or the function directly. We don't have the function. No one can solve this equation for y. But we can still find an expression of dy over dx, or the derivative of y. We don't have the function. We cannot solve this for y, but we can find an expression for dy over dx. Okay, here's a concept that we have to review and connect to other concepts from before. If I want to solve the equation, the square root of x equals 2, what method do I use? How do I solve this?
Square both sides?
Yes, we are applying the inverse function. Why didn't you say cube? Why did you pick 2? You didn't say, well, cube both sides. What
Because it
good?
wasn't a cube root.
Of course, if it's not the cube root, this will not help. But power 2 and power 1/2 are inverses of each other. So we applied an operator to both sides. That's the concept here that I wanted to review with you. If I need to apply an operator, I have to apply it to both sides. What do you think is the operator that we have to apply to both sides to find this, basically dy over dx? Which operator? Do I square? Do I apply natural log? Do I take the cube root? No. But which operator do I need in order to find dy over dx? Will I apply the limit?
Derivative?
Of course. Absolutely. We will differentiate both sides. That's what we need, because we are looking for the derivative. Awesome. Now, this is very important, which this one is not clear, but this one is clear. This notation says y is a function of x. You cannot say that y prime is 1. No. You can say that x prime is 1. But you cannot say that y prime is 1 because y is a function of x that we do not have. So, sign of a function. Outer, inner. How do I differentiate sine y? What should I write?
Cosine y times y prime.
Yes. Excellent. We differentiate the outer times the inner prime. Brilliant. Awesome. Plus, I have to differentiate 2xy. But remember, what rule do I have to apply here? What is it called?
Product?
Yes, of course. 2x prime is
2.
times the second function plus 2x times the second function prime. How do I write the second function prime?
dy over dx.
Awesome. Times dy over dx equals, the right hand side is nice and easy. What do I write on the right hand side?
secant squared x?
Yes. Excellent. Awesome. So now, from this moment on, just algebra. I am after this. This is my variable. This is what I need to solve for. It is found in this term, and it is found in this term. This one doesn't have it. So this one has to be moved to the other side. This moves to the other side from these two because I cannot combine like terms. What do I do if I cannot combine like terms and they both have the variable that I'm interested in? What should I do? Cosine y and 2x are not like terms. They have a common part. So what should I do if I cannot add them? And I need to solve for dy over dx. What will I do?
Factor it out.
Of course, thank you very much. Awesome. Who was that?
That was me.
Thank you. So cosine y plus 2y. Or 2y plus, I'm sorry, 2x plus cosine y or cosine 1 plus 2x, it doesn't matter. Cosine y plus 2x. At this point, we have dy over dx. Can anyone give us the final answer? We are solving for dy over dx.
4 secant squared x minus 2y over cosine y plus 2x.
And this is it. You can say you haven't accomplished anything. You determine an expression for dy over dx, but you still have y in it. Yes, you could say that I accomplished nothing. However, we may not have y, but we may be given a point, x equals a and y equals b, and we will be able to get a number here. So we may not have the y function or f of x, but if we have a point, we can still even evaluate the rate of change of the function we don't have at a particular point. But of course the point has to be on the function. It has to solve the equation, has to verify the equation. So if you say, oh, by simply looking at this, you didn't accomplish much because you still don't have y. But if you give me a point, I will be able to find the value of the rate of change at this point, even if I don't have the function itself, but I have a point. So it's still very